Hi, Alexei. It's nice to
So,
meet you.
nice to meet you as well. So, can you tell us a few words about yourself and about the tool you're going to show us?
Yes, my name is Rick Lammers. I am from the Netherlands and I studied computer science. I really enjoyed it. And during my studies, I got obsessed with data science and machine learning. Took courses in deep learning, model regularization was a theoretical topic I was eventually researching. And I started thinking about how to increase productivity. I really like using computers, but what I like even more is thinking about how we can become more intelligent about how we use computer systems to automate things, to improve the way we do things. And the tool that I'm about to show you is called Orchest. It's a tool that allows data scientists, data analysts to build data pipelines. Data pipelines actually not familiar to everyone yet, but they are a very useful abstraction. You'll often hear them referred to as a DAG, and it basically is a collection of tasks that have a relationship to each other. And so it's an easy way to say, this is the total amount of work that needs to be done, but you need to do it in this order. And very often in a data pipeline, a DAG is a generic abstraction, but a DAG specifically working on data tasks, there's also a lot of data movement because you're typically writing it as like one big transformation where it starts with raw data and it ends up with transformed data, sometimes in the shape of a trained model, but sometimes also just like a different shape of the data and you write it somewhere. So that's what we've been working on the past 20 months at Orchest. It's been a roller coaster ride. We're now a team of 8 people and we're having a lot of fun building it, and we like showing it to people and getting feedback. So
Yeah, I think you have a good designer because your website is awesome. I really like it.
thank you. Thank you.
Yeah, so can you show us the tool?
Yes, so I'll attempt a screen share. Here's to the demo gods that everything goes well. Um, I guess you're seeing it?
Not yet. Now I do.
Okay, cool. So what you're seeing is the graphical interface of Orchest. Uh, I think an interesting contrast between Orchest and some of the other tools that allow you to write DAGs is that we have a more visual heavy approach. And the DAG editor, you can like edit the definition of the DAG. You can edit the properties of these tasks that are like steps in the tag. You can edit them very interactively, but the content of every step is actually just code. So you can switch to the IDE view. You can get into Python scripts that are steps of the pipeline, but you can also have like this IP YNB step, a notebook. So you can edit it and you can actually directly dive into the notebook. But the kernel that spawns in the background is what we call pipeline aware. So it knows of the other steps in the pipeline. So for example, in this case, this notebook receives data from this Python script. And in this kernel aware, pipeline aware kernel, I can just run these steps and actually get access to the data that's being passed. And so I can also look at like, okay, what is the data that's coming in? And I can use that understanding to then develop out the notebook. So in this case, I might want to get a sense of, okay, I fetched the data in the first step, but what is actually being passed in? What does that look like? So I can get the distributional view of the data. And this is typically very helpful because leaving that data exploration as a part of the pipeline can also help you if you run this in production later, as we'll get into when I talk a little bit more about jobs, which is a concept to take this pipeline and run it on a recurring schedule. Then you can,
You save the results, right? So
yes,
because I assume that let's say you run this DAC done workflow every day, right? And then every day you run this notebook and you save the result, the rendered notebook somewhere, right?
exactly. So of
That's cool.
all the executions of the pipeline, you can always view the file. And notebooks have this nice property. Sometimes it's also difficult with versioning, but the good side is that it contains the outputs in the file itself. So as you're running this thing in production, you can make sure that the data that you're reading in the first step, for example, actually contains the distributional shift or maybe some other invariants that you care about, like not having null values or certain values being in a certain range, you can actually have that kind of in the notebook as a way to verify that the whole pipeline is doing what you expect it to do. So it gives you the additional visibility that traditional DAG tools sometimes make a bit tricky, because it's all kind of like hidden in log files, and that doesn't really lend itself to visualization. So it's really kind of the concept where we saw a lot of tools where the prototyping and the proof of concept stage was very disjoint and separate from the production. Pipelines running on a cluster as containers was so disjoint that we wanted to merge them into a single environment that works well for people that are familiar with maybe MATLAB, familiar with RStudio, familiar with Jupyter, and really create an environment where they could thrive.
Yeah, that's really awesome. And this is running on your laptop, or how does it work?
So right now, this is actually running on the cloud service we have. It's a very simple environment where we run the open core on our own servers. And this is very useful for people who are just trying out Orchest or maybe don't want to set up their own infrastructure. So this is just running on AWS servers. And one of the neat things that we integrated is something that you would typically find in something like a bit of a cloud kind of platform, which we actually integrated fully in the tool, which is the container image and environment management. Because a lot of data scientists, they are familiar with the struggle of, okay, how do I actually make the environments identical to what I was using while I was developing my proof of concept, so that when I deploy, nothing breaks, right? There's always this scary jump of like, I hope that environment also has everything it needs to run. Because sometimes, especially in the Python ecosystem, the packages you're using depend on system packages, not just Python packages, right? GraphViz is a very cool package, but a famous example of like, it's not a pip install away. It's like a apt-get or like your system package manager install away. And so what we did is we created a very thin layer on top of Docker containers to allow a data scientist to specify the environment requirements in a bash file. But because that file can reference the project files, a project in Orchest is just a Git repository. It can also install dependencies by referring to files in your repository. So if you want to use a requirements text that is part of your repository of code, you can just use that as an installation step, but you can actually run it here and debug the outputs. So I don't think this project has one. So if I run it now, it will pip will basically say, I don't know, there's no such a file. But you can just go into the file manager in the project's quick start, and you can upload the requirements file. But this is a regular Git repository, so you can also this is actually Orchest quick start. I'll share this tab. This is the quick start. It's the same files you saw just now. So Orchest really allows you to synchronize regularly with Git. It supports Git terminal through Jupyter Lab, but also its GUI. So yeah, it's a Git versioning story.
Mm-hmm. And when you do build, what happens? Does it build like a Docker image, or
yeah? So it builds a Docker image in the background, makes it available in the local repository of the instance. So if it's proprietary, it doesn't automatically get pushed up to Docker Hub, because sometimes it's like back in the old days when people were first starting to use Git, they might push secrets into the Git history without knowing, and they didn't revoke the keys. I think a lot of this has been happening in container image building as well, that they push Docker Hub containers that contains confidential info. Therefore, Orchest by default doesn't push any images to a remote repository, just the local image repository.
And let's say if I want to push it to my ECR, or I don't know, Google Cloud registry or whatever, is it easy to configure?
So at this time, we don't support external image repositories, but we're about to release our Kubernetes version of Orchest that basically swaps the Docker runtime for Kubernetes. We still support running on a single VM. People, like a lot of the current users, they're running Orchest just on like a single virtual machine that they use for their client's project, for their team. And that's still supported by the awesome support of stuff like Minikube. It's fairly trivial today to set up like a Kubernetes cluster on a single node, even though it's, of course, not a real cluster anymore. But still, that suffices for some people. And with that Kubernetes support, we're adding support to also push images to more repositories if that's necessary. But the whole idea is that the scheduler of the pipelines actually also just runs on that Orchest instance and schedules the containers to run your jobs. So I think most people don't have a need to push the image somewhere else.
Mm-hmm. Yeah, that was actually my second question about what do you actually use as infrastructure for running this thing. And you said, so currently all the jobs are executed on the instance, right? So you don't execute things on Kubernetes or AWS batch or nothing like that, right?
So the job running currently runs on the same virtual machine, but the Kubernetes port will basically allow you to then scale up the cluster as you see fit, and it will run it on any of the nodes. That being said, we're also looking at supporting external executors. One of the remote cluster companies called Coiled Computing have a really interesting offering, and we've been in talks with them to think about how could we support running Orchest pipelines directly on their infrastructure. Because fundamentally, and I think this is a really important point, especially for the audience thinking about like how special is this? Like, am I stuck in this thing? Like, is how much bought into Orchest do I need to be to use it? And the answer is not really. Like the full definition of the pipeline is just a JSON file that's added to your repository, and all of the code, even the environment, the script that I just showed you, the bash file, they're all just files in the repo. So we can very easily take the bundle of the repository and create executors to run it pretty much anywhere. And people in the open source community can also even write executors if they need to have custom deployments. So I think that's one of the strong elements of Orchest. The definition of everything that's going on behind the GUI is very clean and simple. So it's very extendable through that nature.
Yeah, that's cool. I have a couple of questions. One was about number of people who work on this. I think you said it's 8, right?
Yes. Yeah, we have we've started this about 20 months ago, early 2020, when we thought, there's an opportunity to build something that will make a lot of data scientists closer to the data and further removed from infrastructure, which we think is for many people the preferred direction to move in, because they don't want to become Kubernetes experts. They don't want to become cloud native serverless computing experts. They want to be
quite common.
Yeah, they want to be
data scientists.
closer to the data. Like what is generating the data? What does the data say? How can we make the data insights useful for the team that I'm also communicating with, right? And so when we started out 20 months ago, we were 3 people, or 2 people initially. Then we got a third person to join us, a fantastic engineer. He's so super good at spotting edge cases. It's insane. Like, I've worked with many people, but he's so good at identifying potential issues. So we've really owe a lot of the reliability of Orchest to him. Then we basically grew from 3 to 8 people in the past 12 months. And we're adding also disciplines now. So we've started with our first designer, and they really think with us about UX design and kind of how to make the workflow even more efficient.
And UI looks very neat, which is not the
Thank
case
you.
for many workflow orchestration tools.
Yeah,
At least for
I'll take
more
a bit of
old
the
school
blame
ones.
for that. I'm pretty obsessed with clean, minimalistic UI, and so a lot of the detail-oriented stuff. Like, I actually implemented these lines that connect them, and I was very adamant about like the behavior of like what happens when they go behind these things. I don't know. I just like I like obsessing over details, but it's a bit of a trap, because sometimes that means that you don't spend enough time on the broad strokes. You just focus on the details.
I think it's important to have a nice user interface. It's not all about YAML, right?
Yeah.
Like, okay, you can do many things in YAML, but at the end, having a nice visualization is also quite
I think
nice.
one of the underappreciated perspectives on that, and especially, not to bash on software engineers. I mean, I consider myself to be one, so I think this is natural. But when you do data science, because I've kind of worked a lot more as a software engineer, but spent a good couple of years working as a freelance data scientist, and the work is actually quite different. I would say the primary difference is exploratory versus like systems thinking and software engineering. And in data science, you often need to be inspired, and you need to discover and explore during the work. Like you're looking at the data, ideas start to kind of like form, and a lot of this can be supported by visualizations. So often you want to be in an environment that's amenable to using kind of the graphical UI you have at your disposal, because in the terminal, in abstract IDE form, thinking about modular code in a very abstract sense, it's very hard to be in touch with what the data is telling you. And as every good data practitioner, I think, will tell you, is that the data can often surprise you to the point that it kind of leads to a breadcrumb trail that if you follow, you might discover you're doing data collection wrong. Maybe you're assigning values in the wrong way. And there's very subtle cues. And I think a lot of that visual elements that, for example, RStudio, in my opinion, really nails with like the plots that are generated. You can quickly go back and look at old plots. That's really important. It's very important, and it's something that doesn't come up as much in regular software engineering. And so I feel like sometimes it's a missed perspective.
Yeah, indeed. Another thing I wanted to ask you about the plans. I think you partly answered that by saying that you soon will have Kubernetes support, and you're working also on integrating external computes. Is there anything else that you plan to do in the nearest future?
Yeah, very much so. So we try to really listen to the users that we have and try to understand what they're missing and what's important. The two big things that are coming up is, in addition to the ones we mentioned, are notifications on failure and very good error reporting about how that failed. So when we started, we focused on getting a really good experience building out the pipeline. So that's like in JupyterLab, editing the steps, authoring the pipeline, looking at the logs, running it interactively, like really the construction phase. But we noticed a lot of people really enjoyed deploying directly in Orchest. It's super simple, right? You go to jobs, you click schedule, boom, you're done. But we wanted to support them much more in that process. So if a pipeline fails for some reason, we want to support sending you a message that says exactly how it failed, why it failed, what the caught exception was, and what the status exit code, like all that kind of telemetry information that you would like to know in order to go into the pipeline and fix it, is what we want to expand beyond what it is now. Currently, you can see the errors in the UI, but you won't get automatically notified. So we're expanding on kind of the quality of life things you would expect from a production like scheduler. And then on top of that, we've heard a lot of people requesting integration with their existing systems because they're not working in a vacuum, right? Like they have existing data infra, they're deploying maybe in a virtual private cloud next to some other microservices that are running. So they would like to see better automated integrations, especially from their like the data scientist wants this, but I can only use it if my software team can make API calls to it, right? So we're building a first stable external facing API that will be basically a control point for the full cluster. So then starting jobs, automated triggers, reading out information about the status of its execution can all be done programmatically for the teams that want to integrate it into a bigger workflow.
Yeah, cool. And you mentioned deployment. How does deployment happen right now? Do you deploy to some external compute like Kubernetes, or the web service runs on the same instance, or how does it work?
So the containers, so maybe as a bit of explanation also, because it's not directly obvious from seeing this pipeline, every step in the pipeline is actually its own container service that is running for the duration of the step. And so this step only takes 12 seconds, so it gets created and it gets removed pretty quickly. But these are all containers that can be scheduled. So these three containers, given by the look of the DAG, they are independent from the data source perspective. So they can run as containers independently. And so we basically have this collection of containers with various execution constraints that we can put onto any container orchestrator. That being said, the current implementation just runs this bundle of containers through Celery on the local VM, but with Kubernetes, that will be on a cluster. We are thinking, basically this comes to the executor story where we think of sending that definition of the pipeline to some external execution environment. But not a lot of users have asked for that yet. Like most of the users are very content running that in the same environment where they've deployed Orchest, because a lot of people have, they figure out where they can run legally given the data they have, and then they want as much of it there, like kind of close to it as possible, is our experience.
I think I misunderstood you. So by deployment, I meant not deploying a pipeline, but let's say you train a model and then you want to expose this model as a web service.
Okay. Sorry. So that perspective is actually, we don't do inference endpoint hosting. So the thing we see people do in Orchest, and also what we recommend, is you train a model, you push the artifact somewhere, maybe through Boto and Python, like you push it to an S3 bucket, and then you have some sort of serverless inference endpoint, maybe AWS Lambda or some other specialized inference endpoint, and you just push the updated artifact to that service. End user hosting of services, it directly in Orchest, especially for endpoints that need to scale because they can handle variable load, we don't recommend you do it in Orchest. The inference case that we see people deploy in Orchest is batch inference. So if you want to have like maybe augment a table with additional data and that table is queried in your application, that's fine. But there's obviously delay. It's not very real time. So for real-time inference, push to kind of a serverless endpoint is what we mainly recommend.
Yeah, I guess it also makes sense to integrate with some model stores like MLflow or some other
Exactly.
things,
So
and then deploy from there.
Orchest was designed from the very beginning to support the very rich and diverse ecosystem of open source tools. So if you want to use MLOps for metric tracing, for model storing, like that's totally feasible. Like with that, from that perspective, it's just like any Python execution environment. You can do as you please. You can also use Comet ML, like any or weights and biases, any kind of tool that you want to use and integrate, you can support. I think worth mentioning is that we have support for services. And that's basically any containerized service that can run as a sidecar to the pipeline. And we can add stuff here like TensorBoard, Streamlit, VS Code. And so that runs as a service directly within the pipeline. And you can use that to expand basically what's running as part of the pipeline. And very often, this can lead to much more smarter or performant pipelines because you can make use of third-party open source applications or even proprietary ones if you want. And so basically, you'll be able to get that running as part of the pipeline.
Yeah, cool, awesome. Last question from me. Do you have any advice for anyone who's now watching this?
I'm going to say something that's maybe not in my interest, but I think it's a general advice that I would advise data practitioners to do is try to not focus too much on the tooling. We are a tool company. We like thinking about tools a lot. We do it every day. And we think good tools are really worth their weight in gold once you find a good way to use them because they make you more productive. But try to just also keep the perspective on, what am I actually trying to solve? What's the business problem? And not get bogged down too much into the technical details and really think about like, okay, how can I create an MVP? How can I show that MVP gives something valuable to the people who have, thought about authorizing the project? I think the thinking about the end goal and trying to get there through iterative steps and not focusing too much on the perfect architecture, the perfect deployment, the perfect Docker image wrapping. I think that's potentially something that a lot of people can benefit from emphasizing more, because then as a field, we'll do better, right? Because the results will speak for themselves.
Yeah, great advice. Thanks. So thanks a lot for joining us today for showing a demo. The tool is awesome. I hope, I am sure many people who watch this will like this and give it a try. And I will include all the links to GitHub. I think it has a pretty nice documentation, right? How to get started with this.
We try our best.
Yeah. So thanks a lot.
Thanks for having me, Alexei. I enjoyed it.